It's Class Online. Welcome once again. My name is Mbarak Omar Abed, teaching advanced mathematics. We are continuing with our revision, and today we are going to revise on application of integration. So before you continue, our subject is advanced mathematics. Our topic for revision is integration. Mainly on application of integration. So as you know, when you are given an integral like this one, let's say from 1 up to 2 of 2x dx. When you integrate here, you will obtain a value or a number. That number is simply as just adding the integral of 2x from 1 up to 2. So we are going to use the definite integral concept to find the area under curves. Now, when you are finding area under curve, we have two scenarios or two cases. When the curve is drawn with horizontal axis or two x-axis, or in the case of vertical axis. Now, let's see one after another. Now, if you look here on the screen, area given the curve is obtained by using the following condition. We have, as I said, we have two cases. Case number one, when the function or the curve is drawn with x-axis or against the horizontal axis. Now, the formula or the curve is like this one. That is y and that is x. So let's assume this is our curve f of x. And we are given the limit from A up to B. So this is the area that you are supposed to calculate. Now the same as adding from A up to B. Now the formula for finding area in that case is given by the integral from A to B of the function f of x dx. So why are we writing the x? Because the graph of the curve is drawn with respect to x-axis. But in the second case, if it is with vertical axis, now you will see the curve will change. Now let's assume this is our curve. This is y and this is x. Let's say you are finding the area from C up to D. This is the area. Now the function will be written now in terms of y and not in terms of x. So it will be f of y. Now which the area now will change and be written as the area of such kind of a curve will be equal to from C to D of f of y dy. So these are the two formulas which are very crucial and that you're supposed to remember them before you go in your examination. Now, where do we use this area formula integral from C to D of f of y dy, and where do we use this one of f of x dx? As I said, this is when the function is with the horizontal line or the x-axis. But this one is when the graph is drawn with respect to y-axis or the vertical axis. Now in that part, let's see what are the key steps that you are supposed to undertake when finding the area under the curve with the given limit or with the given domain of that function. So the following are the steps. And these steps are very important to be seen in part of your solution. So the step to be taken, steps to be taken, or when finding area under the curve. So step number 1, sketch the graph of the given function. Then after sketching the graph in XY plane, I mean this one, the XY plane. So you sketch in that part. After sketching, then you're supposed to shade the area required or between the given limit. And then from there, after shading the graph between the given limit, now the third point or the third step is to choose the appropriate formula, in which here now it's time now to choose the case. Is it in case 1 or in case number 2? Remember, when I say case 1 is when the curve is drawn with respect to the x-axis or horizontal axis. The case 2 is when it's drawn with respect to y-axis or vertical axis. So those are the key steps that you're supposed to undertake when you are finding area under a curve. So as I said, we have two formulas. Formula number 1 is area equal to the integral from a to b of f of x dx. So if you see f of x dx, this is with respect to the horizontal axis or x-axis. And the second one is from c to d of f of y dy with respect to vertical axis or y-axis. So the formula themselves, they express themselves. F of x dx, as we know, the horizontal axis is always named as the x-axis. And f of y stands for the vertical axis. Now to that point, let's check some examples on how to find the area under a curve. Example number 1. But remember, you are supposed to have your calculator beside you because of saving time. Now let's see example number 1. Find the area under the curve y equal to x squared from x equal to 1 and x equal to 2. We are given a curve y equal to x squared. But this one is from x equal to 1 and x equal to 2. So if you go direct without sketching, my dear student, you might get confusion or you can get wrong answer of your question. So as I said, you need to sketch. Now let's sketching the graph of y equal to x square. But you are given x 1, 2. This is the given limit. But remember, when you are sketching the graph, you need to have at least the negative number so as you see the nature of your graph. Will it either turn upward or backward? Upward or downward, depending on the nature of the function. This is a quadratic. We don't know, is it going to turn upward or downward? So we need to draw a table, as is including the negative number. So start from -2, -1, 0, 1, 2. You can add 3. But what are you writing here? You are writing that function y is equal to x squared. Now after that, start substituting. When x equal to -2, this value will be equal to 4. When x equal to -1, here we'll be having 1. When x equal to 0, we'll be having 0. Again, here we'll be having 1, then we'll be having 4, and that one will be equal to 9. Thereafter, let's sketch our graph as part of your solution. So we have 1, 2, 3, -1, -2, -3. Here we have 0, 1, 2, 3, -1, -2, -3. For the case of y, we have only positive numbers. So let's assume here we have 2, 4, 6, 8, and so on. Now when x is equal to -2, our y value is +4. -1, we get +1. When it's 0, we have 0. When it is 1, it's just 1. And when it's 2, is 4. 3 is just 9. Thereafter, using a freehand drawing, join the points. So that is the curve. The curve y equal to x squared. But you have to find the area from x equal to 1 and x equal to 2. Show that area in your graph. So it means from x equal to 1 and x equal to 2. This is the area that you are supposed to find. This is the required area. Now for that case, because it is with respect to x-axis, the formula that we are going to use will be equal to the area from 1 to 2 of f of x dx. Now let's substitute the function and then integrate. Area will be equal to, from 1 to 2, our function was x squared dx. So integrating, you'll be having x to the power of 3 over 3 from 1 to 2. Then simplifying, this will be equal to 2 power 3 over 3 minus 1 power 3 over 3, which is 80 over 3 minus 1 over 3, which is equal to 7 over 3. So from there, you can use your calculator to simplify and leave your answer in decimal places. Seven divided by 3, so we'll get 2.333. But how do I write? Because I remember area is measured in square units. But here we are not given either the centimeter or the kilometer or whatever. So here you just write only square units. That will be the area of the function y equal to x squared in the interval of x from 1 and 2. So my dear student, that is how to find the area of such kind of a curve. Now thereafter, let's check the second example. Y equal to twice x minus x squared. And the x-axis. Here we're not given the limit, but without drawing, you cannot know which limit are you going to use to find your area. So, example number 2. In example number 2, we are given y equal to 2x minus x square and the x axis. So this is the question. Do you know the limit that you are going to use in the formula? Because the formula is area is equal from a to b of f of x dx. Okay, the f of x, you know it. But do you know the value of a and that of b? My dear students, it's not easy unless you draw the graph or you sketch. So here we are going to sketch. But to help you, you can solve for the value of x so as you know which value of x am I supposed to include in my table. Now, sketching the curve. So if we find the value of x from there, so as we know which value to be included in our table, so this one is the same as saying 2x minus x square equal to 0. Taking x out, 2 minus x equal to 0. So here is x equal to 0 and x equal to 2. Okay, so these are the values that are supposed to be included in our table. So x, remember to include the negative number. So we start with negative 2, negative 1, 0, 1, 2, and let's say 3. Then down, write y equal to twice x minus x square. Thereafter, you can write the formula into the calculator and then plug in the value to save time. So do you remember how to write the formula in calculator? Okay, use alpha, then y, alpha equal sign. We are writing that function 2x minus x square. 2 alpha x minus alpha x, then square. Calculating. Calculating when x is negative 2, when you calculate you get negative 8. Again, when you calculate when x is equal to negative 1, you get negative 3. When you calculate is equal to 0, when x equal to 0, here we get 0. Again, calculating when x equal to 1, you get positive 1. When x equal to 2, here you will get 0. When x equal to 3, we'll get negative 3. Those are very enough to sketch your graph. Now let's sketch our graph. This is x and that is y. We have negative number and positive number. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. But in the case of y-axis, we have 1, 2, 3. For the case of negative side, we have negative 1, negative 2, negative 3, up to negative 8. Now plot the point. When x equal to negative 2, we have negative 8. So negative 8 somewhere there. When x equal to negative 1, we have negative 3. When x equal to 0, we have 0. When x equal to 1, we have 1. When x equal to 2, we have 0. And when x equal to 3, we have positive 3. Thereafter, joining the point so as you can see the graph of y. This is the graph of y equal to 2x minus x square. Now the area with x-axis, this is our x-axis. Then this part is the one that we are looking for. This is the required area. So from there, you have seen that we are going to integrate from 0 up to 2. But in the question, we want to given the limit. But after sketching, now we come and observe it is from 0 up to 2. Now let's integrate the function. Now the area is given by a to b of f of x dx from 0 to 2. Our function is 2x minus x squared dx. So it is the same as saying 0 to 2 of 2x dx minus x squared dx from 0 to 2. So if we integrate here, you'll get 2, take it outside because it's a constant number, x squared over 2, 0 to 2. Then we minus x to the power of 3 over 3 from 0 to 2. Therefore, area will be equal to, now substituting the value, we'll be having 2 power 2 is 4 over 2. Then 0 over 2 is just 0, so leave it as it is. Then we minus 2 to the power of 3 is 2 power of 3 over 3. That 0 becomes 0 as it is. So here, 2 and 2 cancel. So we remain with 4 minus 2 power 3 is 8 divided by 3. So if you divide 80 by 3, what are you going to get? So it is 4 minus. Use your calculator again. So 8 divided by 3, we get 2.666. You can approximate the last one. Then minus 4. So if you take 4 minus 2.6667, you will ending having 1.333 square units. Remember to write the word square unit because this is area. Otherwise, if you leave as it is 1.33, just a number, that will be the value of just A and not the area of that curve under the given limit. Now let's see the second example. The first example was on how to find the area of the curve, when it's drawn against the x-axis, in which we use the formula A is equal to the integral from A to B f of x dx. Now, in the second example, we are going to see how to find the area of a curve that is drawn against the vertical axis. Example number 2. Find the area under the curve for which x is positive. So solution, we have y equal to x squared, and we are given from y is equal to 1 and y equal to 4. So if you see that you are given y equal to 1 and y equal to 4, these are the value of limit in the vertical axis. Now, what are the steps? Remember the formula. The formula is area is equal to from C to D of f of y dy. So meaning that the function is supposed to be in terms of y and not in terms of x. So my dear students, here you are supposed to make x the subject, and then thereafter you go and sketch the graph and see which area you are supposed to find. Now, make x the subject. Here we'll be having x equal to the root of y. So this is the function that we are going to sketch. It's graph with the help of the given limit or the given value of y, which is 1 and 4. Now remember, to sketch the graph, you can simply use tabular form, and in which include, now here we are writing the value of y, the value of y, and our function now is x equal to the root of y. So let's just take the one that we are given, starting from 0, 1, you may be having 2, 3, and then 4. Because we're just sketching without using scale. So the root of 0 will be equal to 0. The root of 1 will be equal to 1. The root of 2, you can use your calculator. Find the root of 2. So root of 2 is just 1.4. 1.41. Again, root of 3 is just 1.73. Root of 4 is just 2. It's enough. Or you can add the last one. Let's say 5. If we find root of 5, what are you going to get? We are going to get 2.24. Thereafter, now sketch the graph and see where the area is going to be seen. That is x and that is y. Our y is 0, 1, 2, 3, 4, 5. So we have 0, 1, 2, 3, 4, and 5. But our x here, we have 0, 1, 2, 3, 4, 5. We don't have negative number in the case of xx, because when you're drawing xy plane, remember to add the negative number, and also this side. Thereafter, now starting to plot. When x equal to 0, when y equal to 0, also x equal to 0. The point will be there. When y is equal to 1, x also is also equal to 1. When y is equal to 2, the value of x is 1.4. And when x equal to 3, the value of y, the x value is 1.73. When y equal to 4, the value of y is equal to 2. Equal to 5. So the graph will be of this nature. So that is the curve of x equal to root of y. But we have to find from 1 up to 4. So this is our area that we are going to calculate. So this is the required area. After sketching the graph, what next? Next now is to plug in the formula and then integrate, substitute the value, conclude your solution. Our formula is given by A from C to D of f of y dy. So it is from 1 up to 4. Our function was root of y dy. So let's integrate root of y and see what are you going to get. So if you integrate, it's the same as writing 1 to 4. This is equal to y power 1 over 2 dy. Remember, when you're integrating a function, the power is always increasing by 1. So if you integrate, here will be equal to 1 over 2 plus 1. 1 over 2 plus 1, the same as writing 1 over 2 plus 2 over 2, which is 3 over 2. So it is y to the power of 3 over 2, again over 3 over 2. This is from 1 up to 4. Now the meaning of writing 3 over 2, the same as taking 2 over 3, y that one. So it is 2 over 3 times y to the power of 3 over 2. Then from 1 up to 4. Let's substitute the value. So when you substitute the value, we'll be having 2 over 3 to the bracket. Y is 4 to the power of 3 over 2 minus 1 to the power of 3 over 2. This is equal to 2 over 3. Now, 4, the power of 3 over 2, the same as writing 2 power of 2, 3 over 2 minus just 1. When you take 1 power 3 over 2 is just equal to 1. Then this 2 and that 1 cancel out. So we remain with 2 over 3. 2 to the power of 3 is 8 minus 1. Lastly, will be equal to 2 over 3. So 8 minus 1 is just 7, is over 1. So the same as writing 14 over 3. So the area of such curve will be equal to 14 over 3 square unit. Or you can decide to leave the answer in decimal as this one, 14 divided by 3. So the answer is 4.666 square units. So do not forget to write the units as square units. Now, after that example, now let's see the second example under example number 2. We are given y square equal to 2y minus x and the y axis. That is a tricky question because we don't know the limit. We don't know the limit that we are going to substitute in the integral sign. So you need to work on it, on how to find that one. So example number 2, Roman number 2 is y square equal to 2y x with x-axis. So if you see the word with y-axis, it means this one is against the vertical axis. So step number 1 is to make sure that the function is written in terms of y. So the variable that will be depending is the variable x. So if you make x the subject, so we'll be having x equal to 2y minus y square. So it will be, this will be coming, this side becoming positive, and this one to that side becoming negative. So this is the function x in terms of y. It means here y is the independent variable, but x is the dependent variable. X depends on y to be obtained. Now let's sketch. Sketching the graph. Sketching the curve of x equal to 2y minus y square. And let's see what are we going to get the nature of the curve. Again, you can equate to 0 so as you know which value you're going to include in your table. So take your 2y minus y square is equal to 0. Y, here we have 2 minus y equal to 0. So y is equal to 0 and y is equal to 2. So this value is supposed to be seen in your table value. Again, we write y and then you write x. X is our function 2y minus y square. We have 0 and 2. So we're just adding. We are writing negative 2, negative 1, 0, 1, 2, and 3. So thereafter, take your calculator and write the function so as to save time. Alpha x equal to 2y. So we are writing 2 alpha y minus alpha of y square. Y then is square. So this is the function that you are given, which is x equal to 2y minus y square. Let's see, when value of y is equal to negative 2, what is the value of x? So we do calculate. Calculate when y is equal to negative 2. We obtain negative 8. So that become, so this one will be equal to negative 8. Again, when the value of y is equal to negative 1, we'll obtain negative 3. Here we'll obtain 0. When equal to 1, we'll obtain 1. When equal to 2, we'll obtain 0. When again equal to 3, you will obtain negative 3. So from there, let's sketch and see the nature of our curve. So if you sketch, you will be having the following. This is x and that is y. So in the case of y, we have negative number and positive number. So we include them in our graph, negative 1, negative 2, negative 3. Then we have positive 1, positive 2, 3, 4. In the case of x, we have negative number and positive number again, 1, 2, 3, 4. Here we have negative 1, negative 2, negative 3, negative 4, and so on. So we start with when y is equal to negative 1, our x is negative 3. So negative 1, our x is negative 3. So we have that one. When is equal to 0, we have 0. When we have 1, what do we have? 1 is just 1. When we have 2, we have 0. We have 0. And when we have 3, when we have y is equal to 2, when y is equal to 2, when y is equal to 1, the value of x is equal to 1, that one. And when y is equal to 2, the value of x is 0, we have that one. And when y is equal to 3, we have negative 3. When equal to 3, we have negative 3. Now, joining the point. So if you join the point, you will be having such kind of a graph. But we are asked and the y-axis. So the y-axis, it means this is the y-axis. So the region that you're supposed to find is this part. This is the required area. Now, do you see from which limit you are going to integrate? It is from 0 up to 2. Now, let's go direct to the formula and then substitute the function and then integrate. So the formula is, our function is, so this is the graph of x equal to 2y minus y square. So we say from area is equal to from C to D of f of y dy. From 0 up to 2 of the function 2y minus y square dy. Again, integrating 0 to 2 of 2y dy minus the integral of y square dy from 0 to 2. So if we integrate here, you'll be having 2 to the bracket of y square over 2 from 0 to 2 minus this one the same as writing y to the power of 3 over 3 from 0 to 2. So that part is very easy, substituting time. Okay, so if we simplify now, we'll be having 2 out. 2 power 2 is just 4 over 2 minus y to the power of 3 is 2. 2 power 3 over 3. The one that having 0 will also be equal to 0. So if you simplify, that one cancel, you remain with 4 minus 2 power 3 is 8 over 3. So simply, it's the same as taking this is 1 over 3. 4 times 3 is 12 minus 8. So thereafter, if you simplify, you will get 12 minus 8. You will get 4 over 3, which is the same as writing 1.333 square units. So that is how to find the area under a given curve. Now, from there, hope you have seen the formulas and how to apply them. But thing that you're supposed to take note is to which part of the curve or to which part of the xy plane the curve is drawn with or is drawn against. If it's drawn against the x-axis or the horizontal axis, so the formula that is supposed to be used is the area from A to B, f of x dx. But if it's against the vertical axis of the y-axis, the formula is to be used is from C to D, f of y dy. But here, there is another that you're supposed to know. You must make x the subject of the main curve. So here, remember to make x the subject. As usual, remember all the steps that you're supposed to undertake before choosing the appropriate formula to find your area. That is sketching your graph, showing your area that you're supposed to find, so as to enable you know the limit that you'll be using in finding the area of such kind of a curve. Now, to winding up, here we have question for more practice. I know you have plenty of time staying at home, so don't use that time as granted. Take this question and work on them. Find the area under the curve given below. Roman number 1, y equal to x squared plus 1 from x equal to 0 and x equal to 3. That is question number 1. Number 2, x equal to 4y minus y squared and the y-axis. But remember what I was explaining to you. Those parts are very important or very crucial in application of integration, especially when you're finding area under one curve. So to that point, hope you enjoyed the lesson. Don't miss the next lesson.